So here we are. Now this is going to be different, and that's kind of what I was warning you. What you're looking at is you're actually looking at three planes. Each one of these equations is a plane. So you've got three flat pieces of paper coming together. If there's a solution, that means that the three are going to intersect at a point, where two of them will intersect at a line, and the third one is coming in and intersecting somewhere on that line. It is possible that you get no solution or an infinite number of solutions, but the geometric interpretation changes a bit. If you get no solutions, that means that the three planes never intersect, or at least two of them never intersect, so they're parallel. But the third way, when you have infinite solutions, you can have that where one of the planes is actually just nothing more than a copy of the other one. So it's a little bit weird, but we're not going to worry so much about the geometric. If we can get it down to two variables and two equations, then we can put it into Desmos. We can graph it using Desmos and then solve it that way. So here we go. This is going to take some good secretarial work, I'm telling you. So if you don't like to write, this probably won't be for you. I am going to start by labeling my equations. 1, 2, 3. And the reason I do this is because it's a lot of work to write down every single thing. So I'm going to write down what and tell myself what to do. Alright, so let's start. The easiest way to do this is through elimination. So when you're going through this, if you love substitution, it can be done. It takes like 3 to 4 times longer, but it can be done. Remember, our goal is not so much to get down to the full answer, but at least to get down to two equations and two variables so we can solve from there using Desmos. I am going to choose, and the way I make my choice is I look through all my variables, and what I'm trying to do is I'm trying to choose a variable where it's easy to multiply through. If I look at, for instance, in number 1 here, I look at the x's. To go from 2 to 5, I have to multiply by something that's not easy. So it's 2.5, and you can do it. You can multiply the top equation by negative 2.5, and then you could eliminate x's. But that's not very easy, especially when you take 2.5 and you multiply it by 9, because you're going to get another decimal. So if you take a look at z's, 2 will multiply into 8. That's good, and they're opposite in sign, so that makes it even easier. But 2 does not multiply into 9 very well. And so I'm going to choose my y's to eliminate, because y has a 1 in front of it, and 1 times 6 is 6, and they're opposite in sign. And so I'm going to choose that route. So I'm going to take, I want to write myself a note here. So I'm going to take 6, I'm going to multiply that into equation 2. And when I do that, after I do that, I'm going to add that to equation 1. That is going to eliminate y. When I am done, I'm going to call that equation A. And I'm not going to have any y's left in it. So here's what this looks like. 6 times equation 2. This is going to be 6 and then 5x plus y plus 2z equals 10. And so if I distribute that 6 through, it's going to connect all 4 of those pieces. That's going to give me 30x plus 6y plus 12z is equal to 60. And then if I take, I don't think I want to, I'll do green. And then if I take number 1 here, I can put number 1 beneath it, and this is going to be 2x minus 6y plus 9z is equal to negative 8. And now I told myself I want to add them. And so that's what I'm going to do. I'm going to go and add down the columns. So I get 32x. 6 minus 6 is 0. There are no y's. So these will eliminate. And then I get 12 plus 9, which is 21. So 21z is equal to 60 plus negative 8 is going to be a positive 52. And as I'm going through this, I'm looking, can I reduce this at all? Because that's pretty nasty looking. It doesn't really look like a can. 32 is made up of 2's, and 21 is not even. So that's kind of unlucky. Oh well. So I'm going to call this A, and I'm just going to kind of set it aside. Next step. So now there's this idea of a pivot, and so you're going to always have two pairs of these equations, but one of them will be used twice. And the one that's used twice is kind of referred to as a pivot. And it's a little bit different when we talk about linear algebra, but which is a study of this exact thing. But it kind of plays the same role. So I'm going to take now, instead of 2 and 1, I'm going to take 3 and 1. And I'm choosing 3 and 1 because of that I can multiply by 6. That being said, if you were like, hey, yeah, but if you multiply 3 by a negative 1, then you can add it to 2 and eliminate the y's. Yes, you can. Go for it. Do it. Try it. What happens? Do you get the same answer? All right. I'm going to go ahead and go back to my old route of just multiplying by 6, but I encourage you to try that on your own. And so I'm going to tell myself again, what am I doing? So I'm going to take 6 times equation 3, and then I'm going to add that to equation 1, and then I'm going to call that B. So that's going to be 6 times 3x plus y minus 8z equals negative 28. You might be thinking, yeah, it looks really good now, Mr. Collins, because you got to multiply 6 and 28. You're right, I do. So maybe my decision should have been, hey, multiply this bottom one by negative 1 and then add the two together, because 38 is a lot easier to do than 6 times 28. So again, I encourage you to try it. This will give me 18x plus 6y minus 48z is equal to, and now, this is going to be 168, negative 168. 6 times 2 is 12, so it's 120. 6 times 8 is 48. 120 and 48 is 168. All right. Now drop number 1 below it. And so this is going to be 2x minus 6y plus 9z is equal to negative 8. Add these two things together. This is going to give me 20x. The y's will eliminate. And if I subtract 9 from 48, I get a minus 39z. That is absolutely awful. And then I add these two together and I get a negative 176. So this is B. All right. So now I've got this down to 2 equations, 2 unknowns. Here's where we have to be a little bit cautious. So what I'm about to do is use Desmos to finish this out. Now you can actually go through and continue the process, and you can use elimination or substitution to solve these, and then back substitution to solve all of it. I'm going to choose to use Desmos, but when I do that, I have to be extraordinarily careful. Desmos doesn't like z's. Desmos only likes x's and y's. Whoops. And so when we do this, oh, come on. No. Just do that. Thank you. When we do this, I need to rewrite these, but I need to be careful that I do them correctly. I'm trying to get back over here. All right, so here's my Desmos work. Desmos. Do it in blue. Desmos. I'm going to write a little note to myself that says z is equal to y. Now, the y in the original problem and this y are not the same. So this is one of the reasons we have to be careful. So I'm going to graph 32x plus 21y equals 52. And that would be like on line 1. And then I'm going to graph 20x minus 39y equals negative 176. And that's going to be on line y. And then I'm going to get a point. And that point is going to be x comma y. Then I need to change that to x equals and z equals, because I'm faking the z with the y. So let's go ahead and jump into Desmos here. All right, so I've got Desmos. So I'm going to take 32x plus 21y equals 52. Next one I'm going to take is 20x minus 39y equals negative 176. My apologies. So where they meet, I click that point. And so my x value is negative 1. My z value is the y value, which is 4. So then I come back here to my work. All right, so I've got x equals negative 1, z equals 4. So I'm going to plug that into one of these three original equations to find y. I'm going to choose the bottom equation, just because I'm throwing one out. I just had to choose one. So, all right, so this is going to give me 3 times negative 1 plus y minus 8 times 4 equals negative 28. So now if I combine like terms, this is going to give me a negative 3, a negative 32. This is y minus 35 equals negative 28. And so y is going to be 7. So there's my y value. Here are my x and z values. My final answer is negative 1, comma, 7, comma, 4, called an ordered triple. These do not have a limit. And so the general idea of getting an answer like this is called an ordered n-tuple. Ordered n-tuple. So that'd be like an ordered 10-tuple, because we're lazy, and after a certain amount of time, it's like triple, quadruple, quintuple, and then sextuple, septuple, octuple. It gets really nasty. And so eventually we just get to the point where just like, it's a 17-tuple, whatever you want to call that, because it's gross. But this is your answer. That's where the three planes will meet in 3 space. So if we're in the classroom, this would be like me standing in the corner by the board where the fan is, and then it's negative 1 on the x, so I'd actually walk 1 foot towards Mr. Neville's room. I would walk 7 feet towards my desk, and then I'd have to jump up 4 feet. And that's kind of where these planes would all meet, if you want to think about it in a 3-dimensional space. So what I would do is, if you need to, rewatch this video and exactly what I did. I'll give you some hints on the next one, or in the next 2, I should say. But rewatch it until you fully understand. I probably, given the size of some of these multiplications, I can see that if I were to choose the second one as my pivot, I see that multiplying the bottom one by 3, the top one, oh no, that doesn't work, does it? We probably shouldn't do that. I really wanted to start with the y's, and I'm like, yeah, but that looks really nasty, so I was trying to be a little bit better about it. But it's looking like, because, oh no, that works. That works. This can be pivot. That's fine. I would recommend either x or y, because then for the pivot in x's, so I'll put the x's here. I would take 1, 2, 3. I would take equation 1, 2 times equation 3, and then, it should be a negative 2. Negative 2, because I got to change signs so that they eliminate one another. And then I'd add equation 1 to it, and I would get equation A. Then I would go back. I would take negative 3 times equation 3. Well, I'm not doing a very good job of this, am I? I'm kind of mentally deficient this morning. My pivot was the one I used twice, so that's number 3. This is my pivot. I'm screwing it up because it does mean something different in the other. And it doesn't have to do with the equation so much as it has to do with the leading coefficient. If you take pre-calc, then we'll talk about it, but it's really not that bad. And then that goes to B. And so you would want to take like -2 times equation 3, add that to equation 1. That will eliminate the x's. Take equation 3, multiply it by -3, add it to equation 2. That'll take care of the x's. You don't want to mix and match. So if you choose x's, eliminate x's both times. If you choose y's, eliminate y's both times. It does not matter, but you just have to keep going on one of the letters. Otherwise, you'll have 2 equations and 3 unknowns, and that doesn't work. If you wanted to eliminate y's, your pivot would be this guy. And again, it's not that bad, but you'll notice that the y here that has the 1 is opposite in sign of the other two. You don't have to worry about multiplying by a negative. So it'd be just 4 times equation 1, and then I'm going to add that to equation 2. That would give me A. I would take 7 times equation 1. That would add that to equation 3. That would give me equation B. These are 2 options to do number 2. When you are done, so and you get these down, you still have those 3 options of solution styles. So if I just quickly bring up number 4's notes, which if you don't have that, that's because you turned it in with your homework. So I'm kind of redrawing it here so you have them. You had one solution where you had maybe a line coming in like this, maybe a line coming in like this, and wherever they meet, that's your solution. You had no solution because the 2 lines are in fact parallel. And then you had infinite solutions when one line was over top of the other. And the way that you could see that in Desmos was over on the left, you can shut off one of these graphs simply by clicking on the color. And if you shut it off and the whole thing is underneath in the other color, then you have one line sitting on top of the other. And for that, you'd have an infinite solution set. So once you get down to two equations, 2 unknowns, throw it into Desmos. Yeah, I don't expect you to do this thing fully by hand. If you want, you can. It's not that hard to do, but it just takes extra time. All right. I'm not going to leave you guys hanging. I'm sorry I couldn't be there today, but I have to take my son over to Kalkaska to get a final fitting for his retainer. We are hoping that this is the last thing that we have to do for orthodontics. And so tomorrow, which will be Friday, then we can go over it. I can do some more examples on the board. You'll notice that according to this video, I did one full example and gave you some advice on the second, and it's almost 20 minutes long. These things take a while. They don't just happen. And so it kind of gives you an appreciation for when the computer goes about doing it, even though it looks fast, it's not doing a 3x3. It's doing a 500,000 by 500,000, and it still takes time, which is why AI takes time to train. So, anywho, all right. I will see you guys tomorrow. If you have any questions, let me know.